everyone, I'd like to review for our Feedback Friday number 3. So let's just do an example together. So I have a particle that moves across a horizontal line according to the standard position function x of t, where t is greater than or equal to 0, t is measured in seconds, and x of t is measured in feet. The v of t function is given below. So take a minute, pause the video, and write down the v of t function and what I'm asking. And then hit resume when you're ready to continue. So I want to find the acceleration at time equals 3 seconds. So the first thing I need to do is find the acceleration function. And the way that I do that is I take the derivative of v of t. So if you want to write that down, a of t is equal to the derivative of v of t. So I'm going to start with my v of t function. Just going to rewrite it. So negative 3t squared plus 36t minus 81. And I want to find my acceleration function. And I do so by taking the derivative. So I'm going to multiply the power by the coefficient. So I'll have negative 6t, drop the power down by 1, plus the derivative of 36t is just 36. And the derivative of the constant 81 is just 0. So if that's my a of t function, if I want to find the acceleration at 3 seconds, I'm just going to go ahead and put 3 here. So I'll have negative 6 times 3 plus 36. So take a minute, plug all of this into the calculator just the way you see it. Pause the video and then hit resume for the answer. Okay, so you should get that a of 3 is equal to 18. And if you want to be specific about units, you can. I'm not really worried about it too much. So my acceleration at time equals 3 seconds is 18. So that is the answer for part A. All right, let's look at part B. So I just rewrote the velocity function, and part B is saying, when does the particle change direction? So if you want to take some notes down, the particle changes direction when there's a sign change. So when there is a sign change from positive to negative or negative to positive. And we're going to have to do our v of t number line to answer that question. So step 1 is we're going to set v of t equal to 0 and solve. So let's do that. So we have 0 equals negative 3t squared plus 36t minus 81. I believe you could take out a GCF of 3, so I'm going to take out a negative 3 so I don't have to divide by a negative. And I have t squared minus 12t plus 27. And we're going to find numbers that add to negative 12, that multiply to 27, and that number is minus 9 and minus 3. So I have time equals 9 and time equals 3. This is more specifically where they are at rest, and we're going to have to just confirm that that's where they change direction. So I'm going to draw myself a nice little v of t number line. I'm going to put 0, and I'm going to put 3 and 9. So I want to go and test some values. So I'm going to test in between 0 and 3, I'll test 1. In between 3 and 9, I'll test 5. And after 9, I will test 10. So go into the y equals of your calculator and type in your v of t function, because this is our v of t number line. So negative 3t squared plus 36t minus 81. And we're testing our values at 1, 5, and 10. So go ahead, pause the video, and then hit resume when you're ready for the answers. Okay, so when I plugged in 1, I got negative 48. When I plugged in 5, I got 24. And 10, I got negative 21. So minus, because of the negative, 24, plus because of the 24, and minus because of the negative 21. So this is where the particle is moving left. This is where the particle is moving right. and this is where the particle is also moving left. So it's clear that where they're at rest is actually where they're changing direction. So we have time is equal to 3 and time is equal to 9 is where they change direction. Okay, let's try the third part. So I want to know where the particle is now speeding up or slowing down. And remember, when you try to find where it's speeding up or slowing down, you want to compare your v of t number line with your a of t number line. If the signs are the same, then it's speeding up. If the signs are opposite, then it's slowing down. So I want to actually just copy the v of t number line that we did before. So here's my v of t. We had 0, 3, and 9, and it went minus, plus, minus. So we're going to keep that, and now we're going to make an a of t number line and put it below. So for this a of t number line, we need to find where a of t is equal to 0. So let's do a of t is equal to 0. So remember, our acceleration function from part A was equal to negative 6t plus 36. And I'm going to plug a of t is equal to 0, and I'm going to solve. So I'll subtract 36, and then I'll divide by negative 6. So 6 is where acceleration is 0, so I'm going to go ahead and put 6 here. And we do have to test a couple of values for our acceleration. So I'm going to test 1, which will be here. And then I'll test, say 10, which would be over there. So again, go to your y equals, but this time you're putting in your acceleration function, negative 6t plus 36, and test the value at 1 and at 10. Pause the video and then hit resume when you're ready. Okay, so for 1 I got 30, and for 10 I got negative 24. So what that positive 30 means is that this would be positive acceleration and this would be negative acceleration. So we're looking for where the signs are the same and where the signs are opposite. So I just need to draw in a line. So I'm going to draw a line in between here, in between this 3 and the 6 and the 9. It'll just clear things up a bit. So if you can see, from 0 to 3, we have positive and negative. So that is going to be where it is slowing down. So I'm going to put for down that it is slowing down between 0 and 3 because they have opposite signs. And here they have the same sign. Here they have opposite signs. So from 6 to 9, it is also slowing down. And then we want to do where it is speeding up. So we're going to do speeding up is then the opposite, where the signs are exactly the same. So from 3 to 6 right here is where they are the same. So we can go ahead and say from 3 to 6, union from 9 on is where they are the same. So we will say 9 to infinity. Perfect. All right, let's look at part D. Okay, part D says, find the standard position function given that x of negative 1 is equal to 20. So remember, to find the standard position function, we have to integrate v of t. So x of t is equal to the integral of v of t dt. So x of t is equal to the integral of v of t dt. So I'm going to integrate. Remember, add 1 to the power and divide by that power. And 81 just gets a t, And don't forget the plus c. And then we can simplify this a bit and say x of t is equal to negative t to the third plus 18t squared minus 81t plus c. And in order to find that c value, we're going to have to plug in our x and y. So my x is negative 1 and my y is 20. So 20 equals negative 1 to the third plus 18 times negative 1 squared minus 81 times negative 1 plus c. So take a minute, catch up with the writing, plug all of this into the calculator, and then hit resume when you're ready for the answer. All right, so when you type all of that in, you should be getting 100. So we should get 20 equals 100 plus c. And to solve for c, we just have to subtract 100. So negative 80 is equal to c. So my final answer for my x of t function is negative t to the third plus 18t squared minus 81t minus 80. And that is my final answer for x of t. All right, let's move on to the next part. Okay, so part E is asking us to find the total displacement over the interval from 0 to 6. So just know that displacement can be found in two ways. So you can choose which way you'd like to do this. So the first option is to find x of b and subtract x of a. And the second option is to integrate v of t dt over the interval from a to b. Now I'm going to do both ways so that way you guys can pick which option you feel most comfortable with. So to find the interval for a to b, a is going to be 0 and b is going to be 6. So I'm going to, for option 1, to find x of b, it's x of 6 minus x of a. So what I'm going to do is I'm going to take this x of t function and I'm going to put it into my y equals in my calculator, and I'm going to look at what the value is at 6 and what the value is at 0. I don't know why I put a there, so this should be 0. So why don't you take a minute and evaluate those numbers and then hit resume when you're ready for the answers. Okay, so at x of 6, I should have 134, negative 134. And at 0, I should have negative 80. And when you subtract them, you should get negative 54. That is your displacement. The other way to do it is to integrate over the interval from 0 to 6 of your v of t function. My v of t function I'm going to say is negative 3t squared plus 36t minus 81 dt. So take a minute, throw all of this into your calculator using the Math 9 option, and hit resume when you're ready for the answer. And you should also have gotten negative 54. So either way you do it, you'll get the displacement. Okay, let's move on to the next example, and I think this is the last one. I want to find the total distance now over the interval from 0 to 6. So remember, we have two options. Option 1 is using the x of t function, and option 2 is using the v of t function. So if I'm going to go through the x of t option, remember the way that we have to do this is we have to use our table of values, x and then x of t. And the endpoints of the interval go in the top and the bottom, so 0 and 6. And then the values that would go in here are actually where v of t is equal to 0, or in other words, where it changes direction. So I believe we answered that in part B. So go to where it changes direction, and let's just look. I believe we had time is 3 and time is 9. But be careful because the interval that I want the distance over is only from 0 to 6. So we're actually not going to use the 9, but just the 3. So take a minute, put your x of t function into your calculator, and tell me what these three y values should be. Try it on your own first and then hit resume when you're ready to continue. Okay, so the y values you should have gotten were negative 80, negative 188, and negative 134. So when finding our distance, the best way to do this is to do a picture. So I'm going to put my picture over here. So actually we'll do option 2 on the other slide. So we're going to put these y values, negative 80, negative 188, and 134 on this number line. So I have negative 188 is the smallest, then should come negative 134, then negative 80. And just for perspective, 0 is somewhere over here. So we're watching the pattern. We're starting at negative 80, then we're moving to negative 188, and then we're moving back to 134. So this is at time equals 0, this is at time equals 3, and this is at time equals 6. So what we want to figure out is the distances between those spots, and then we just add them together. So the distance from here to here, and then the distance from here to here. So we want to know how far it is from negative 80 to 188. So you can kind of disregard the negatives and just subtract these two. So 188 minus 80. So go ahead, type that into your calculator, and you should get 108. And then we want to find the distance from 188 to 134. Again, you can disregard the negatives and just really subtract these two. So 188 minus 134 is just 54. And to find the total distance, we would add them. So 108 plus 54, and that gives you 162 for a total distance. All right, let's do the other option if you wanted to use the v of t function. Okay, so for this problem, the points of interest that we need are going to be the endpoints of the interval, so the beginning, which is 0, where it changes direction, which we knew it changes direction at 3 and 9, and then we need the endpoint of the interval, which the endpoint of this interval is time is 6. So I can even put over here that this is time is 0. And we can also conclude that we're going to reject this 9 because it's not within the interval. So we actually have to break up the integration in two parts. So we're going to integrate from the beginning to where it changes direction, and then from changes direction to the endpoint. So we're going to do the integration of 0 to 3 of vt dt, and then we're going to add that to the integration from 3 to 6 vt. So I'm going to do that over here. So 0 to 3 of negative 3t squared plus 36t minus 81 dt plus the integral from 3 to 6 of negative 3t squared plus 36t minus 81 dt. Now I'm going to use the calculator and I'm going to use Math 9 to type these in. So why don't you try that on your own first and then hit resume when you're ready to continue. But don't forget that you have to take the absolute value. So when you put the first one into the calculator, you should have gotten negative 108. So we have to take the absolute value of that. So we get positive 108. So 108. And then when you put the second one into the calculator, you get a positive 54. So when you add them together, 108 plus 54, you get your answer of 162. All right, that's it. Good luck working on your Feedback Friday. If you have any questions, please let me know.